Recall host will be done at any time the participants may. Okay. So today we are going to learn simulation. Okay. Simulation is a very important thing for justifying your result. In other way, simulation is happening almost any adventurous or maybe adventurous movies. You know, in the Hollywood movies, if there is some very dangerous scenes to take, the real actor, he is not acting. Instead of him, a third person is acting, right? You know that, right? Because life could be in the dangers that could be. So real scenarios is completed by the another person. So in our statistics, most of the time we end up with decision for the one data, right? One data. But you have to justify that one result is good. Suppose you come up with a model, then you are claiming that your model is very good. Understand? Your model is very good. You come up with the data or you come up with a model and you say that your model is very good. And then you are saying that, well, I fed this data and that data is giving us very good result. And then people say that, well, this is just the only one data. By chance, one data could be very good for your model. How about if you try your model on a multiple data sets? So in such a cases, if you simulate the data from the same scenario from where original or real data is coming, and then you run the model again and again, and you find the average and then coverage probability, average and mean square error to check whether your model is good or not. Okay, this is what. Now, I'm writing in here. So everyone know about this, right? This is called binomial distribution. Q to the power n minus x, where x takes value 0, 1, 2, up to n. And P is the probability of success. So you know these distributions, right? This is called the binomial distribution. There is a lot of applications of these distributions. For example, if a hospital has 50 patients, so n equal to 50. And probability of a COVID patient is 0.70. Probability of a COVID patient is 0.70. Find the probability of exactly 10 COVID patient. Okay, how can you find that? 50, choose 10, 0.7 to the power 10, 1 minus 0.7 to the power, Q means 1 minus P. Q means 1 minus P, then 50 minus 10. That is the way you can find the probability of a COVID patients. Okay, this is one of the examples. And then suppose the coin is tossed 10 times, and or maybe you are interviewing for a job and the probability of getting a job is 0.50. And what is the probability that you will get exactly 2 job offer in a 7 interview? or what is the probability that you will get at least 5 job offer. So those are the things you can compute for at least 5 job offer. So if n equal to suppose 10 interview, at least 5 job offer, that means equal to this one. At most 5 job offer, that equal to this. These are the things can be obtained by binomial distributions. Here x equal to what? X equal to probability of success. Probability of success. And n equal to what? Number of trials. Sorry, x equal to number of successes. P equal to probability of success. I am very sorry. P equal to probability of success. This is P. P equal to probability of success. X equal to number of trials. Trial. And x equal to what? X equal to number of successes. Number of successes. X equal to number of successes. We are going to learn how to simulate, how to generate X. Okay? We are going to learn how to simulate, how to generate X by using Python. Okay? So first 5 problems are simple, and then the 6th problem is also simple, but there is a combination of all of this. You have to simulate from a equations, and then you have to compute theoretical mean, theoretical variance, and then you have to compare with them with the simulated mean and simulated variance. But today we are going to learn how to simulate data from probability distribution. How to simulate data from probability distributions. How to simulate data. How to simulate data from probability distribution. Okay, so let us take a look at the first problem. First problem is asking you, take a random sample from binomial distribution with p equal to 0.7, which is probability of success, and size equal to 10, and number of trial equals to 10. What does this mean, size equal to 10 and number of trial equal to 10? So size means number of sample I want to take. This means that you have 10 coins, which you toss 10 times. 10 coin, I toss first, 10 coin I toss, I got 7 head. 10 coin I toss second time, I got 5 head. 10 coin I toss third time, I got 4 head. In that way, I want to toss 10 coin 10 times. 10 different types of head will appear. That is the meaning. So in order to understand what this Python code is doing, second line, which is telling you, this means that you have 10 coins which you toss 10 times and probability of appearing head is 70. So compute the mean and variance of this simulated data and repeat this procedure for 100 times. This repetition must be random. Then estimate the mean and variance. Compare it with the mean and variance of the binomial distribution. True mean and variance for the binomial distribution is this. Now, if this is the binomial distribution, it has a mean. Expected value of x equal to NP and variance of x equal to NPQ. Okay, so take a look at that. Our n equal to 10 and p equal to 0.7. So average number of head is 7. Okay, average number of head is 7. This is called the theoretical mean. So our number of trial is 10. I am tossing the coin. Probability of head equal to this, probability of tail equal to that. 2.1, mean and variance. So mean and variance 2.1, mean is 7, variance is 2.1. This is called the theoretical mean and theoretical variance. Now we want to generate X. Are you seeing expected value of X? Expected value of X equal to 7 and variance of X equal to 2.1. Now by using Python, we will generate X and want to check whether that mean and variance is close to 7 and 2.1. Okay. Okay. Now let me take you to the Python. So I imported a package known as NumPy. And then after NumPy, I put here, are you seeing I wrote there without randomness? Without randomness means you generate one data, then you want to replicate it multiple times. No randomness. That is called the without randomness. For example, if I run this and then run 0.7 and then run this, take a look. S equal to what? S equal to 88877866677. Okay, your result must be different from my result because it is randomly generated. So what does this mean? First 8 means I tossed the 10 coin. First time I got 8 head. Second time I tossed the coin, I got 8 head. Third time I tossed the coin, 10 coins, I got 8 head. And 10th time I tossed the 10 coins, I got the 7 head. You understand? I want to find the mean of this. Okay. If you want to find the mean of this, you will find around 7. Okay. If you want to find the mean of this, you will find s dot mean 7.2. Understand? What was theoretical mean? Theoretical mean was 7. So this is just, I generated 10x, which has a mean 7.2. Now, if you run line number 15, and then if you take a look at that one, B1, what I did, I replicated this 5 times. So same thing is coming, right? Same thing is coming. Are you okay? You P1, you in the data change it to 7. Change it to lucky 7. Are you seeing, is there any randomness? No, right? So what I did, S was generated on line number 14. I just multiplied by 5 times, and then this is the generated. Okay. So that does not make any sense. Same thing is generated, same thing, right? But we want to do randomly. We want to do randomly so that second one, third one, fourth one, fifth one will be different. Each is different from the other. Clear? So what should we do? We go to the line number 23, and line number 18 and 19 and 20 are doing the same thing as we have done in line 14. This is the different way of writing line 14. So line number 18 and 19 is same as the line number 14. Now come to the line number 23, and I find the mean is 6.81, variance is 2.14. Okay, variance is 2.14. So now if I want to change it to 100, so this means there will be a 10 row and 100 column. Let me run this. I change it to 100 and then write it as 2. So there is a now if you find the mean 7.01 very close to the theoretical mean, right? Very close to the theoretical mean. So you will focus on simulation line 23, 24, 25, 26. Okay. And then we can check theoretical mean is 7. Now simulated mean is coming 7.019. Theoretical variance is 2.1. Now simulated variance is coming 2.11. Clear? Any question? So very simple. You must pay all of your attention when I will discuss about your homework. Okay. In the last 30 minutes or 20 minutes, I will discuss about your homework. But this is just the how to take data from a binomial distributions. And then finally, problem number 6, I am taking data from different distributions and combining them together in a one format. Okay. And then finally finding theoretical mean and variance from equations. Okay, let me discuss now second distribution. Second one is take a random sample from Poisson distributions with lambda equal to 3. Poisson distribution, as I mentioned, this is the binomial distribution. NCX p to the power x 1 minus p to the power n minus x, where x takes value 0, 1, 2 up to n. And this is the Poisson distribution. X equal to x e to the power minus lambda, lambda to the power x over factorial x. Here x takes value 0, 1, 2 up to infinity. Okay. It has a mean. It has a mean expected value of x equal to lambda. It has a variance equal to lambda. I will show you by mathematical derivation why this is true. Expected value of x equal to lambda and variance of x equal to lambda. Only statistical distributions that has same mean and variance. Okay. I will show you. Maybe I can show it right now, but what is the purpose? Purpose is to simulate, purpose is to generate x. All of these, x is our variable, right? Variable. What is the difference between variable and random variable? What is the difference between variable and random variable? But all other variable that also has a real number. Your age, my age, your granddad age, it is real number, right? There is a real number and complex number. There are no other number, right? You are close, but there is something else you have to add. What? No. Someone else? Any girl from here? From here? What is random variable? Random. It has certain probabilities. Understand? If there is a certain probability, then what is the advantage? You can predict with some level of certainty, right? Are you understanding? So, what is the difference between variable and random variable? So, variable and random variable, never forget these things. Variables means any characteristics or circumstances that vary persons to persons, places to places, circumstances to circumstances. Okay, this is called the variable. Places to places, persons to persons, circumstances to circumstances is called the variable. On the other hand, what is random variable? Random variable, it is a mapping. It is a function or mapping. Let me explain you what does this mean. It is a function. It is a function or mapping from sample space to real line. What does this mean? It is a function. I said function, right? Function has what? This is a function, right? F of x. If you put x, then you have to write here x square plus 1. Right? Is it a function? F of x equal to 2. Is it a function? It is a function or not? Is it a function or not? Okay, I write fx equal to 2. What question you can ask me? You ask me a question. Is this a function?
No, it's not function. It's not include the x.
Okay,
Or y.
you are saying that there
not
must
include
involve
X or-
x, right?
X or y, yeah.
X or y. Okay, so he's saying this. X is in here, fx is in here. Okay, this is 1, this is 2. This is 2, right? I am taking x equal to 1, y equal to 2. I am x equal to 2, y equal to 2. X equal to 3, y equal to 3. Y is so stubborn. Y does not care anyone. Y said that I am always 2. Whatever value you can x take, I don't care. It is a function. It is a function. Okay? It is a function. Now I'm going to tell you this is a function. So I have to write random variable in this fx format, right? In order to convince you this definition. What is the definition? Definition is this. What is the definition? Definition is this. Definition is this. It is a random variable is a function or mapping from sample space to real line, right? So I have to write something like this. I have to write something like this. So let me write something like that. Let me write something like this. I'm tossing 2 coins, HH, HT, TH, TT. I'm tossing 2 coins, HH, HT, TH, TT. So how many coins I'm tossing? 4 coins, right? No, this is the 2 coins. This is the 2 coins. How many coins? 4 coins. So if x equal to number of heads, okay? And then this is a 4 head, 3 head, 3 head, 2 head, 3 head, 2 head, 2 head, 1 head, 3 head, 2 head, 2 head, 1 head, 2 head, 1 head, 1 head, 0 head. Understand? Are you understanding? X equal to what? Number of heads, right? Now, I want to put it in there. This is a real line that starts 0, 1, 2, 3, 4. This is my sample space, right? So it has a 4, it has 3, it has 2, it has 1, it has 0, right? How many 4 head? Only 1. How many 0 head? Only 1 sample point, right? So if I put there x from there, x, if I put h, h, t, h, right? Then it will move to where? 3 head, right? Right? So that means you can write this is our x is a function h, t, h equal to 3, right? Is it a function or not? So random variable is a mapping from sample space to real life. Random variable is a function. from sample space to real value. So what is the underlying thing? Are all of these has the same chance of occurring or not? No. Why? Each sample point has the same chance, but number of one head has a different probability than number of four head, right? Number of two head has a different probability than the number of three head, right? Okay, let me explain these things to you again. X equal to 0, 1, 2, 3, 4. And probability of X equal to 1 over 16, 1 over 16, right? And then 4 over 16, and then 4 over 16, and 6 over 16. Okay? Do you agree or not? Each sample point, each of the 16 sample point have an equal chance, but value of the X does not have the same chance. Are you understanding? X has 4 different values. Their probability is different, right? So random variable is what? Random variable has a associated probability with the real number. Random means there is a probability. Clear? So you understand the difference between variable and random variable. In the simulations, we always generate X's, that means variables, that means values from the probability distributions. Okay. Now, let me show you one thing. Then I will go and generate. So probability of X equal to X equal to the power minus lambda, lambda to the power X over factorial X, and X takes value 0, 1, 2, up to infinity. Okay. And that is called binomial distribution. And Cx p to the power x, 1 minus p to the power n minus x. Here, x takes value 0, 1, 2, up to n. So this one is called the Poisson distribution PD. This one is called the binomial distribution BD. For the binomial distributions, I can show you by numerical example that this function actually calculates the probability of success. 4-coin tossing experiment, if I compute 4-coin tossing experiment, probability of appearing 0, 1, 2 head, which is 6 over 16, right? 6 over 16 from the sample space. This is what? This is what we computed. This is what we computed from the sample space. But I can also compute 6 over 16 in here. Take a look how. We have 4, choose 2, half to the power 2, 1 minus half to the power 2. So then this is equal to 6. This is equal to 4. This is equal to 4. This is equal to 6 over 16. Similarly, for each of the scenarios, each of the 5 scenarios, 0, 1, 2, 3, 4, I can compute this probability from the sample space as well as from this mathematical function. I can convince you. Intuitively, you will be convinced, and also your psychology agree with your eyes and everything that this mathematical function is computing binomial probability of success. Are you understanding? Because I showed you, right? The problem is those type of intuitions, those type of psychology, those type of like visualization would not be able to convince you about this distribution. There is no way, no intelligent person on the planet among 8 billion people can be convinced by looking at the mathematical function. Well, this mathematical function, well, that's fine. This is exponential distribution that make intuitive sense. No. Do you understand why I am telling these things? This binomial one, you intuitively, I have shown you by manual computations from the sample space as well as from that. But this does not. Why? Why? Because Poisson distribution is mathematically derived. It come into this existence, the Poisson distributions. This come into an existence, Poisson distributions, x equal to x, e to the power minus lambda, lambda to the power x over factorial x. These come into existence from binomial distribution under certain conditions, and see x p to the power x 1 minus p to the power n minus x. In this binomial distribution, if you consider lambda equal to np and p goes to 0 and n goes to infinity, these three conditions, if you apply on binomial distribution and do some mathematical manipulation, you will end up with Poisson distribution. You understand? If someone working in there, he said that I totally agree, totally understand binomial distribution is derivations. That function actually calculate probability of success when there are two cases. I have computed these things manually and I have checked it. I agree with that. But I do not want to agree with the Poisson distribution. Someone write the function and then I have to agree with that. If some people argue with those type of argument, the counter argument is what? Counter argument is that Poisson distribution is derived from the binomial distribution under this condition. What does this condition means now? Probability of success P equal to 0, very close to 0. And number of trials is very large. What does this mean? In a busy traffic accident, how many cars are passing? In a 24 hours, every second, if you consider a moment, so busy traffic intersections, lot of cars in every moment passing, right? So 24 times 60 times 60, that will be the number of seconds, right? Right? 24 times 60 times 60. So if that is considered as a long time, how many? That is if seconds, if you consider a lot of seconds, right? So n goes to infinity, and then in the whole day, the number of accidents could be 1 or 2 or maybe 0. So the time is this one, 24 hour, each hour has 60 minutes, each minute has a 60 seconds. This, if you consider this as a n every second, then n is a very big number, right? I'm giving you rational. And then this time, probability of accidents, very small, right? Maybe on that intersection, whole week, there is no accident, right? Are you understanding? So they plug these value in the binomial distributions, they end up with Poisson distributions. So Poisson distribution is applicable when, suppose in a telephone exchange, now lot of phones are coming, one or two phone call is a wrong number. People misdial that. Number of accidents taking place. So this is the scenario where we can apply exponential distributions. Clear? Okay. So now let me take you to the, okay, let me quickly derive these things. I want to derive only on, I don't want to spend a lot of time on that. So I said expected value of x equal to lambda. Okay, let us derive this big. Expected value of x, what is the definition? Sum of x, p of x equal to x, and x takes value 0 to infinity. So now if you plug the value x equal to 0 to infinity, x in there, e to the power minus lambda, lambda to the power x over factorial x, then what are you going to get in there? 1x cancelled out with this, so there is a x minus 1. I want to 1 cancelled out, so it starts from 1. And then I want to take out e to the power minus lambda, and 1 lambda I want to take out from there. This is what. Can I write this line equal to that line? Take a look. There is a 1x cancelled out with this x. So here is x minus 1. Okay. There is a lambda times this one. So lambda to the power x. And e to the power lambda is a constant. I just take this out. E to the power minus lambda. Okay. So now if you plug the value to the power minus lambda and then plug the value, then you will get 1. You will get lambda 1 lambda square 2. You will get like that, which is written like e to the power minus lambda e to the power plus lambda, which is equal to lambda. That is the way we can derive the mean of the exponential distribution. Okay. So some intelligent people, they have the binomial distributions, they have the Poisson distributions. They just like to play some game. Well, put this condition in India. They put the condition n p equal to lambda, right? And then n goes to infinity and lambda p goes to 0. After those conditions, they come up with these things. They said, well, let us find some real life scenario. Real life scenario what? So time is very long, but the event probability of happening an event is very small. Okay. So that's the way Poisson distributions come into in existence. This is the only distributions that has mean expected value of x equal to lambda equal to variance of x. Let me tell you. Suppose you have a count data. You have a count data. What is the count data? Suppose you went to India and you went to Uttar Pradesh. Uttar Pradesh, you investigated, suppose 1,000 women. Okay, 1,000 women. Their age from 20 to 90. 90 years old women, she said that I have altogether 11 children. Are you understanding? And 60-year-old women said that I had altogether 5 children. And 30-year-old women said I had 2 children. Understand? So what are you finding? Number of children for each woman from age 20 to 90, right? Age 20 to 90, number of children. And number of children, 11 children, 7 children, 6 children, 5 children, you can find their mean and variance, right? If mean and variance of the number of children are the same, then you can use Poisson regression. Understand? Why? Because Poisson distribution has the same mean and variance. Number of children, the women give birth. Or maybe I can call each of you. How many scam phone call you can get? So each of us can say that I got 3, I got 7, I got 8 scam phone call, right? I want to find the mean and variance of the scam phone call. And if mean and variance are the same, I said that, well, let us do the Poisson regression. Okay. So now I want to generate the data, simulate the data. Let me take you to the Python. So we will not focus on here. This is just a non-random thing. We will focus on there. This is what we have done. And then we find the b equal to what? 3.5. Let me find the mean. 3.52 I found. Okay. If I increase it, and then variance I found 3.92. Okay. Mean and variance is close. Mean and variance is close. Okay. Any question? Anyone has any question? So what we have learned how to simulate data from probability distributions. These probability distributions is the heart of the statistics. They are used for predictive modeling. Okay. Now let me go and discuss. Anyone has any questions? So if you have ever any questions, I know many of you do not have a science background or maybe do not have a calculus background. So I created a document. Each time if you have any problem, read the document and try to match the code. In that way, things will be easier. Okay. Take a random sample of size 10 from uniform distributions with A equal to 0 and B equal to 20. Okay. A equal to 0 and B equal to 20. What does this mean? This is the uniform distributions. Uniform distribution. F of x equal to x. Here is B minus A, and then x takes value B to A. This is the way it has been written. So more specifically, it could be written 1 over 20 because 0 less equal to x less equal to 20. 0 less equal to x less equal to 20. Okay. So this has a mean. This has a mean. Expected value of x equal to a plus b over 2, which is equal to 10, and it has a variance of x, which is equal to b minus a square divided by, I guess, 12. 12. Okay. So now if you plug here, 20 minus a equal to 400 divided by 12, 3, 3, and 3, 4, something like that. We want to simulate the data from this distribution, and we want to compute the mean and variance from the simulated data and check whether the simulated mean and variance coincide with the theoretical mean and variance. Okay. Are you understanding? This is simple one. Then we will discuss the problem number 6, which will combine all of this. So now let me take you to that one, uniform B, uniform 0 and 20. We should focus only on the randomness one. Take a look at the line number 58, where I wrote np.random.uniform 0, 20, and n2 is the number of times I'm taking the sample, and then n2 is declared before, and then I'm doing it 100 times because 100 applications. So this is what I got, and then mean 9.88, which is close to 10, and then 32.75. So theoretical mean was 10. Now our simulated mean is 9.88. Okay, simulated mean is 9.88, and then simulated variance is 32.75, which is close to 33.34. Clear? You have question? Here, 58. Here, okay. 0 to 20, the uniform distributions, 0 to 20. What does that mean? So here, I stop in here x, okay? So height equal to like this. This is equal to 1 over 20, okay? This is what? So This is 0 to 20, okay? 0 to 20. And then N2, if you take a look at the data, I want to find N2 equal to 10. Are you seeing? The line 33, N2 equal to 10, okay? Now, if I want to run this, and then S1, so there is altogether 1000 number. That 1000 number is mentioned in here. But when you write like this way, for example, if you change it to just the 10, take a look at that, what I'm getting. This is 100 observations, okay? Clear now? Because in the question I said randomly replicate it 100 times, so that's the reason. Uniform distributions. Now I want to discuss normal distributions. After normal distribution, then exponential distributions. After exponential distributions, I will use this one, number 6. Okay, number 6. You have to understand these things, and I will discuss maybe 20 minutes or 25 minutes about the homeworks problem. Okay, because homework problem are related to the question number 6. And the 7, 8, I did not want to discuss in here, so I ignored 7, 8, 9. So 6 is the most important. 6 incorporate all the things that I did previously. Okay, let me start discussing normal distribution. Normal distribution has a mathematical format like this. F of x, mu is the parameter known as the mean, sigma is the standard deviation. It is written like that, twice phi sigma square e to the power minus half sigma square x minus mu square x less than infinity, and then mu equal to less than infinity and sigma equal to greater than 0. This is a normal distribution, also known as the Gaussian distribution. Okay. Now, standard normal I am discussing. This is normal. You know, people, even though they are abnormal, they said I'm a normal guy. Right? I'm a normal person. Sometimes they just think, but actually they are not. They are very high level person. Abnormal means I'm not saying like the bad sense. Abnormal means they are very high official, or maybe very talented students, or maybe very talented entrepreneur. But they people always like normal. Okay. If all people are normal in the world, then there will not be any cause, any chaos, right? You see, Putin said what when Biden paid it cheap, I destroyed entire world. I don't care if someone is threat for the Russia. Okay, I'm just scared of when I'm going to hear something like some. Accidentally, if a nuclear weapon blasts in the atmosphere, in the space, all of us are connected with the cell phone, right? Electromagnetic wave, electromagnetic pulse, read those things. Electromagnetic pulse, read those things. In American Senate, they discuss about this things. How can? And electricity will be gone forever, like the way Michael Faraday discovered electricity. Like the from the people will go back to the without electricity world. You understand? So why I discuss this thing in the morning, I see that our president visited Ukraine, And then after his visit, he immediately canceled all types of nuclear treaty with the United States. All types of nuclear treaty. If you already by verbally, if you already heard some of your friend or your mother or sister, this is the time to beg excuse. You understand, right? Okay. People always say no, but yeah. That deviated me to discuss about something. I'm very worried. Like every day I read something. When this, it will be not just like I will give you one punch. Okay, I give you one punch. Give me one punch. This is not. It will once it will start. Okay. God make all of us normal. We want to be normal distribution. It has a lot of application, normal distribution, lot of applications. Lot of applications. How these come into an existence? If someone said that, well, I do not understand this function. I'm walking there. You write some function and ask me normal. I don't understand. Again, this is derivation. This is derived. You understand? If someone want to understand these things intuitively, well, I want to understand this function intuitively so that it will consistent with my thought process, something like that. This is coming from mathematical derivation of binomial distributions. It is coming mathematical derivations from Poisson distributions and some other distributions. And a statistician, mathematician says that if sample size become large, all distributions become normal. You remember I discussed skewed distribution, right? Skewed to the right, right? I discussed skewed to the left distributions, right? And that they are saying when samples is more and more sample size increasing, and then all distributions become normal distributions. And mathematically, this is called the CLT. This is mathematical called central limit theorem. Central limit theorem. Mathematically, they are saying all when the sample size increases, data become normal, and normal distribution has a frequency curve like this way. How did you get this frequency curve? How did you construct this curve, that curve, that curve? How? You already forgot? No. How did I get this frequency curve? What graph? What graph? Histogram. See, you lost your interview question. You lost the job opportunity. So if they will ask you in the interview, how did you get? Do you use the normal curve? How did you got the normal curve? Your answer is data is in there. We construct histogram. We add the top middle point of each bar, and we got the frequency curve. Clear? We got the frequency curve. This is coming from the frequency. What we are computing in here. You already started computing these things, right? What is the probability or percentage in here, right? What is the probability and percentage in there, right? What is the probability and percentage between in here? This is what called the normal distribution. Okay. So this is the normal distribution. This gentleman said, what is standard normal distribution, right? So this is the normal distribution. Probability of x mu comma sigma is written as twice phi sigma e to the power minus half sigma square x minus mu square. Okay. When you transform this by using this, for example, suppose x you have 10, 15, 12, 20, 15, 20, 20, something like this. You have x like this. Okay. This is your x. This x has a mean, right? This x has a mean. Suppose that mean equal to this x has a mean, expected value of x has a suppose 20, and standard deviation of x
standard deviation of x, suppose 5. So now you can compute z, which is equal to x minus mu over sigma. Suppose 10 minus 20, you got 2, you got 1. Suppose, I'm not sure what will be. I'm just showing you. You got 0, you got 3, you got 1, something like that. Clear? You have a x, you computed the mean of x, you computed the standard deviation of x, you subtracted mean of x from x, and you divided it by the sigma, then you get a new z. This z has a mean 0 and standard deviation 1. Understand? If you don't understand, let me quickly do these things for you. If you don't believe me, if you are a great unbeliever of me, so I have these things, okay? I have these things. I am generating 50 normal numbers, which has a mean 10 and a standard deviation 2. Clear? I generated these things. A. So now what should I do? I am creating B. How? A minus mean of A and divided by standard deviation of A. I'm showing you real life example as D of A. Now my B, that means Z is created. Z is created. Z is created. Now take a look at it. Take a look at this. Mean of Z equal to what? Mean of Z equal to what? Minus what? Minus, it is very close to 0, right? No? It is very close to 0, right? It is very close to 0. Now you have to convince the standard deviation, right? And it should be 1, right? So what I did, this line of code, random binomial, I am generating 50 random normal, which has a mean 10 and standard deviation 2. I subtracted mean from this generation divided by standard deviation. I convince you that mean of the Z equal to 0 and standard deviation equal to 1. You understand? So now, as you are convinced, these things, these distributions become that. This is called the standard normal. E to the power half Z square. Take a look at that. This one is called the normal distribution. This one called the standard normal distributions. Clear? 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 This is called the standard normal distribution. This is called the normal distribution. That is called the standard normal. Now tell me. Answer my question. If there is a normal distribution, why do we need standard normal distribution? If there is a normal distribution, why do we need standard normal? The white dog sitting in there and can answer my question. You always listen and you need to contribute something. So what she said, the problem is, if we will be strict in here, if we are strict, we should be strict on the normal distributions, then there is a billions of mu, billions of sigma, right? How? American people height is different from the Asian people height, right? American people weight is different from the African people weight, right? Are you understanding? So American people mean weight is different from the African people mean weight. American people mean blood pressure is different from the Australian people blood pressure, right? Billions of normal table needs to be constructed for values of mu and sigma. They said that we subtract mu divided by sigma, we make it standard normal, so that in the standard normal, there is no mu, no sigma. Clear? You understand why we need a standard normal? Now this standard normal, if you want to live in a Mars or Jupiter,
you can use this table. No. Even though I give you a problem in African countries, the height of the African people, average height of the African man is 6 feet, and their variance of the height is 0.75. Okay, find the probability that a randomly selected person has height greater than 6.1. You do not need to go to the normal table. What you will do? 6.1 minus 6. Why? 6 is the average height. Divided it by 0.75 becomes standard normal. So this table
Anyone can use in the world. Here is my standard normal table. This table you can use. Okay? This table. Mean equal to 0, standard deviation equal to 1. You are already using this like in other courses. R. Okay. You can calculate it R. But when we are students in late 90s and early 20, master's student, so during the exam time, our professor give us this table. We have to use this table. But they give everything in a normal format. We have to transform it. We have to transform it to a standard normal format in order to use this table. You understand? But nowadays, as computer is in there, it doesn't matter. Whatever mean and variance you put, you will give you the result. Okay? What she said, I'm showing you. She said it's called pnorm 2.3, 0,1. Okay? This is what she said. What does this mean? 2.3 means is this. 2.3 is this. She is 2.3 is this. This is 0. This is 2.3. And pnorm means all of this area. All of this percentage of frequency. This is called percentage of frequency or probability. Okay. So 2.3 equal to what? Let me check it from the table. 2.3. This is 2.3. 0.98. 9893. 9893. 9893. Are you saying 9893? 9893. Pnorm. We can use directly their normal distributions. How? Suppose mean equal to 10, standard deviation equal to 2. Okay? Okay, I give you explanation and rationale, the applicability of normal distributions. Normal distributions, the mathematical functions that you see, it came into an existence from a mathematical derivations. It has a mean, mu, and standard deviation sigma. It has a lot of real life applications. Okay, a lot of real life applications. So I want to, the mean is 10 and standard deviation is 2. We replicated it 100 times, directly come in here and run this and check the result. Mean should be equal to 10. So I find here and variance. Are you seeing variance is 4.06, right? Our standard deviation is 2. 2 square equal to what? 4. So this and that matching. Line 189 and line 187 is matching, right? So line 187 is a standard deviation, square of which equal to 4, right? Clear? And then let us check the mean. In order to check the mean, let me write the NP dot mean equal to S1, which is equal to 10.03. But you know, even statisticians become super happy when they feel that their data falls in standard normal distributions. There is a normality test Shapiro will test. If you have a data, you can run a test to check whether that data follow normal distributions. Okay? Clear? That is, everyone like normal distributions like this time. But when it is the matter of achievement, everyone always like in here. Do you understand what I mean? Top 1%, top 2%, right? Are you understanding? Top 1%, top 2%, top 3%. Okay? Okay? If you are in here, everybody will say you are in average. Right? Then if you are in here, bottom 5%. Okay? So people like always in here. Always in here. Okay. So I have simulated data from normal distributions. I see there are 5 online persons. Anyone has any question? Eric, Hassan, Ray, Subira, Vaishnavi.
Yeah, it
Are
is
you
fine.
understanding?
Yes.
Good. Eric, are you okay?
Yes, I'm doing fine. Thanks.
Good, good, good. Okay, let me do now exponential distribution, okay? After exponential distributions, then we will go for simulating from equations, exponential distribution. Exponential distribution looks like this. 1 over lambda e to the power minus 1 over lambda x, and then x must be greater equal to 0, lambda must be greater equal to 0. What will be the problem if lambda is less than 0? What will be the problem if lambda will be less than 0? If lambda will be less than 0, what will be the problem? If lambda will be less than 0, then what will happen? It will not be defined. In what sense? You're correct. If lambda is less than 0, then it will become. If lambda less than 0, then this part will become positive, right? If lambda less than 0, then this part will be positive, right? If lambda less than 0, then this part will become positive, right? Right? And then x takes value greater than 0. So that means 0 to infinity, right? And then if you integrate this, you are destroying the everything. It will explode, right? E to the power x, can you integrate this? E to the power x, 0 to infinity? Oh my goodness. Can you integrate this? E to the power x, right? And then infinity to 0. Then what are you going to do? Oh my goodness. You are destroying everything. So this is the exponential distribution. So this condition must be satisfied, and then expected value of x equal to lambda, and variance of x equal to lambda square. Okay. I can prove these things. I can derive these things, but just I want to save some time. I don't want to derive these things. This could also be written, exponential distributions could also be written like that. Lambda e to the power minus lambda x. Condition is same. Lambda must be greater equal to 0. X must be greater equal to 0. In that case, mean should be 1 over lambda and variance could be, variance of x could be 1 over lambda square. Exponential distribution has this type of curve. All human beings, all creatures on the planet follow exponential distribution. All creatures. How? Take a look. This is my x. This is my fx. Okay. I born in here 0 year, 1 year, 2 year, up to suppose here 100 year. So my survival curve will go like that way. Right? When I was born, my probability of survival is very high, right? And then going down, right? All creatures follow this curve. Exponential distributions. There is a subject known as the survival analysis. And that survival analysis, there is a regression model known as the Cox model, failure model, accelerated failure model. All of those things is done from this type of concepts: exponential distribution, Weibull distribution, double exponential distributions, all of this. Okay. So biostatistics, biomedical, all of those, they study these things, exponential distributions. Okay, so now let me go and run this. Normal distribution is done. Exponential distribution, I consider 2. And after doing this, these things is non-random. I do not need. Let me run that one. And then I have 2 L1. And then the mean is 2 point this. Okay. And variance will be close to 4. So that is the way we can generate the data. So I have discussed 5 probability distributions: binomial distribution, Poisson distributions, uniform distributions, normal distributions, and exponential distributions. I have given some of their characteristics. Now I am going to ask you a question. Suppose a person is walking down the hallway. He came and wrote in the board and asked me this question. Hey, Dr. Chaudhary, is this a probability density function or probability function, something like that? He said x greater equal to 0, x greater than 0, and lambda greater equal to 0. You understand? Any person told me I am walking, is this a probability function? When a function is called a probability function, what is the definition of a probability function? Probability function has 2 types. Probability mass function. Probability function has 2 types. It has two types, probability. Function has probability. Function is called PMF. Another one is called the PDF. PMF means probability mass function. Probability mass function. Mass function. This is called probability density function. When your random variable is discrete, when your random variable is discrete, it is called probability mass function. When your random variable is continuous in the numerical scale, it is called the probability density function. Clear? Now, any function? No, you don't understand? Okay. So, probability mass function means random variable must be discrete. And probability function, mass function or density function are for random variable. And what is random variable? I already discussed, right? Okay. Probability mass function is for discrete variable. What do you mean by discrete? They take isolated value, number of accidents, okay? Number of successes, number of failures. Clear? On the other hand, if any value is in the numerical scale, so that means can take any numerical value, decimal, non-decimal, that is called the probability density function. Probability density function are for the continuous variable and probability mass function are for the discrete variable. Clear? Now, when a function is said to be, let me write it. When a function is said to be a PMF or PDF. Understand? When a function, mathematical function, when a mathematical function is said to be a probability mass function or probability density function. Never forget these two conditions, okay? Number one, the probability function must be greater or equal to 0. That means it must be positive. It must be positive. It could be fx or it could be px or p of x equal to x. It could be greater or equal to 0. You remember when I write binomial distribution and Poisson distribution, I write it in p format. When I write exponential and normal, I write it fx format, right? This is the notation people write. Any function that must be positive all time. Whatever value you will plug, it must be positive. If it will be negative, then it will not be a probability mass function and probability density function. Number two, second condition. Summing of probability mass function equal to 1 or integrating of probability density function equal to 1. When you will integrate? When random variable is? When you will integrate? When you will integrate? When you will integrate? When continuous variable. When your random variable is continuous, you will integrate. Okay? When your random variable is discrete, you will sum. Okay? Are you seeing two conditions I have written, right? When a function is said to be a PMF, probability mass function or probability density function. So probability mass function and probability density function has two conditions. One condition is that this must be positive. Whatever value of x and parameter you will plug in the function must be positive. And when you sum or integrate, that function must be 1, equal to 1. So because total probability equal to what? Total probability equal to 1. That's the rationale. Understand? That's it. Okay. Now, probability mass function generate what? Probability mass function PMF will directly give you probability. Will directly give you probability. That is why it's called the mass. It has a mass. Clear? For example, probability of x equal to e to the power minus lambda to the power x over factorial x. Suppose lambda equal to, according to the condition, lambda cannot be negative. Suppose lambda equal to 2 and x equal to 5. Then take a look what I'm getting. X equal to 5, lambda equal to 2. 2 to the power 5 over factorial 5. This is the positive number, right? E to the power negative, e can never be less than 0, right? E to the power anything, whatever you put, it can never be negative, right? The way E has a definition, E equal to 1 plus 1 over factorial 1 and then 2 over factorial 2. That's the way it's go, like x over x over like this, x square, x cube, something like this. Clear? It has a mass. If you plug the value in there, you will get a probability in there. Can anyone of you quickly compute these things, what you will get? E to the power negative 2 times 2 to the power 5 divided by factorial 5. Are you computing? Yeah. Tell me. NP dot e to the power exp negative 2 times 2 to the power 5 divided by factorial 5. Oh, factorial is not finding. How did they write? Oh, NP dot factorial maybe. Factorial. How did the factorial write in Python? See, I taught these things in class. Now I forgot. Factorial. How did I write factorial in Python? What? It's just like factorial. Anything? So let me write NP dot nope. Factorial. No, it is not getting. Did I make a spelling mistake? What?
Put by the letter, the F.
What?
You put the F by the capital letter, F factorial.
What should I write? You did it R.
You have to read the F by capital letter.
Capital
Yes.
F?
Yes. Hmm.
How many of you have already started using ChatGPT? Oh, my goodness. So you are already getting everything, right, for the homework? Python code for factorial. Math.factorial, but I do not import. Math.factorial. I got 0.03. You got the same? Okay. Now take a look. I got here 0.037. This is probability, right? I am showing you something which you need to understand. This is a Poisson distribution. I plug the value of x equal to 5 and lambda equal to 2. I got a number 0.037. From probability mass function, you always get probability. Clear? Are you okay? From probability mass function, wherever you will go, you will always get probability. It will be in a point value or in a range value. Do you understand what do you mean by range value? Range value means if you want to sum this probability of x greater equal to 5, right? This is a range value, 5, 6, 7, 8, 9, which you can find 1 minus probability of x less equal to 4, right? Right? Probability mass function, you will always get probability. Either it is in one point, which is equal to probability of x equal to 5. You are finding probability at a point x equal to 5. Or at a summation of point, which is probability of x greater equal to 5. But when you find PDF value at a point, that is not a probability. Let me write it. You, all of you, either pay attention or some of you who are interested to write, you can write it. At any point of a PDF, we do not get probability. At any point of a PDF, we do not get probability. Are you understanding? Are you understanding? Now I write something, I have to convince you by giving you an example, right? Are you understanding? What I said, for PMF, probability mass function, you will get probability at any point or at sum of points or at less than sum of points. For example, I have computed this probability at point x equal to 5. We got the probability which is equal to 0.037. we got the sum of this probability, which is also must be less than 1. That means between 0 and 1. We can also find the probability of sum of less than a number. Here is sum of greater than a number, less than. But in PDF, this is not true. See an example. Ready? What did I say? For the PDF, at any point, if I compute, if I integrate, we will not get probability. What is the name of that? Are you understanding? Are you understanding? For PDF, now I have to convince you. Take a look what I am writing. Take a look what I am writing. I am writing these things. F of x equal to twice x, and twice x takes value 0 and 1. Okay? First thing, I have to check whether this is PDF or not. Right? Is this a PDF? First condition satisfied, right? It is continuous, fantastic. It is first things is satisfied because f of x is greater equal to 0. Okay? Even abnormal person cannot make it 0, right? It is always greater equal to 0, whatever value you will plug. First condition is satisfied. Second condition is integrate 0 to 1, fx dx will give us what? 1, right? So do this thing, 0 and 1, twice x dx, we will get 2 x square over 2, and then 0, 1, we will get 1 square minus 0 square, which is equal to 1. Clear? Clear? So the condition of a PDF is satisfied. Right? Now I am plugging something in here. Take a look. If I plug in there 0.9, what we are getting? 2 times 0.9, which is equal to 1.8. Are you understanding? Is 1.8 is a probability? Is 1.8 is a probability? Probability lies between 0 and 1, right? Right? So I took a function which is equal to fx equal to twice x, and I showed that fx equal to twice x is a PDF, probability density function, because two conditions are satisfied. And now I put here 0.9. 0.9 falls between 0 and 1, right? And then I got 1.8. What is this 1.8 now? What? I do not listen you. What is that 1.8? Could you tell me louder? Loud? 1.8 is 1.8 is what? If any graduate students, if you ask, this is what, but I got 0.9, what I get here, 1.8. Lot of graduate students around the world make a mistake. Are you understanding? You have a clear idea what is PMF. You have a clear idea what is PDF, right? PMF, probability mass function. Whatever value you will put in the PMF, it will give you probability. Understand? I want to convince you that is this true for the PDF? In order to convince you, I come up with an example, right? And I prove that this is the PDF. Two conditions satisfied. Now I plug 0.9, I got 1.8. What is the name of 1.8? What is the name? What is generated? Probability distribution function. Probability density function, fx equal to twice x equal to probability density function, that is fine. Because two conditions satisfied, right? So now 1.8 equal to what? 1.8 equal to what? 1.8 equal to what? Online people, can someone of you help me? Can anyone from the online want to contribute? Okay. Never forget these things, okay? When it is PDF, then this PDF, if you plug any value in the PDF, then you will get rate or change of rate. Clear? Understand? But when you integrate PDF, you generate probability. Clear? That function, twice x, you can integrate any limit, 0 to 0.9, 0 to 0.2, 0.9 to 0.1. Any limit, if you integrate, that will generate probability. But pointwise, it is rate. Pointwise, it is rate. Understand? From PDF, pointwise value of the PDF is a rate. Clear? And I give you the explanation what is rate. Remember? You remember? So 10 people make $90 today. You remember this example? I didn't give this example in the class. 10 people make $90 today. The same people make $80 yesterday. So what is this? The difference of rate, right? Per person rate was $8 yesterday. Per person rate is $9 today. 10 person worked for me yesterday for my home. Understand? This is the rate of difference of the rate between yesterday and today, right? Can I transform this as a calculus? Take a look what I'm doing. Take a look what I'm doing. This is a 10 in here. I got 90 minus 80, right? Clear? Okay. Now can I write like this? Can I write like this? F of x plus h minus fx divided by x plus h minus x. Can I write like this? Can I write like this? So fx plus h equal to 90, fx equal to 80, and then x cancel, h equal to 10, right? H equal to 10, right? Take a look at that. What you do it in here, fx plus h minus fx, and then you put here h, right? And then what you add, just h goes to 0. And then you name it as this, right? Do you agree or not? So that is in discrete scale. 90 divided by 2 minus 90 divided by 10 minus 80 divided by 10. That is in a discrete scale, right? But differentiation is for the continuous. Every second I want to find. Every second I want to find. For example, this is the curve, right? I was in here. Here is x. I want to go just little bit tiny, which is x. Now here is x plus h, right? So here my rate was this. My target is to reach in here. My target is to reach in there. Okay. So my slope, my rate was in there. I am reaching like that way, right? And then little bit changes in there. Little bit changes. Now my rate is in this way. right? Are you understanding? So the little bit change in the denominator, how much change in the numerator? They said x equal to tends to 0 because if you consider 1 second, 1 second has a lot of millisecond, right? Right. So if you take a look at the New York Stock Exchange, every second the stock price is changing, right? Elon Musk make a tweet and the stocks went up. He said 2017, I took Tesla private. And then Security Exchange Commission, now they investigating him. They will make a fine against him. He makes sometime, I will take Bitcoin if someone wants to buy Tesla by Bitcoin. You understand? Then Bitcoin price went up. So the top positions come up with top responsibility. If you will go to the top positions in your life, just take two advice from me. Always be truthful, always be honest. These two weapons are very sharp. Nobody can fight with this weapon. And if it will always be in your heart, mind, and mentality, you will see your life will be very smooth. Take these two pieces of advice. And soon you will hear the verdict the Security Exchange Commission will give, because you are a CEO of a company. Your company is doing business with the public money, stock exchange, right? Stock exchange. And you can tweet something and then go up and down. Some people make money, some people lose money. You cannot do that. Why I am saying that? Because in stock exchange, every second, every millisecond, stock price goes up and down. That is in the continuous scale, and this continuous scale is in the range. You understand? The differentiation, integrations, all of these things, it is in continuous scale. Every second I want to take a look, I want to take a change. So they have a function, they integrate this, they differentiate this, they find this value. So you understand the clear difference between PMF and PDF. PDF will give you rate if you plug pointwise value. That is not a probability. Clear? That is not a. In order to get the probability, you have to integrate. But for the PMF, it is always probability. Are you understanding? Question? Comments? Problem? Personal problem that you do not want to share? No? Okay. So now let us do these things. Let us do number 6. Number 6, what we will do? We will generate x1, x2, x3, x4, and then finally we will put all of these things together in a y. And then I want to find the mean and variance of the y, which will be the theoretical mean and theoretical variance of y. And then I will compare, I will find the expected value of y, and then I will compare this with the simulated mean and variance. Okay? Are you understanding? So first 5 are the simples. Now this is going to little different. For example, let me write it in here. Can anyone of you please help me by telling me the equations? Anyone computer is open? Y equal to what? 3x1 log 34 plus e. Okay. So now take a look. How can I find the mean of this? Expected value of y equal to 5 plus 3. Expected value of x1 plus log of 34 plus expected value of e to the power minus x2 plus e to the power 5 x3 5 x to the power 4 0. Okay, expected value of E equal to what? Okay, now tell me the expected value of E, right? This is the way I am finding theoretical mean. Okay, so 5. This is X1 is binomial, right? Could you tell me X1 is binomial, right? Binomial with N equal to what? P equal to what? Okay, and then log 34. This is what we have to compute. 0 to infinity e to the power minus x2. X2 is exponential of what? And x3 is a 0 and 10. So mean equal to 5. Okay, 0 and 10, 0 plus 10 divided by 2 equal to 5. And then 5, x4 is a normal with mean what? 20. Variance 9. Expected value of E equal to 0, right? Are you seeing? This is the way I can find theoretical mean. Okay. So theoretical mean I'm finding 5 plus 3, n equal to what? N equal to 20. And P equal to? So NP equal to what? 20 times 0.65. One point three. 1.3 log 34 plus 1 over 5, 0 to infinity to the power 1 plus 1 over 5 x2 dx2 plus 5 e to the power 5, 20 times 5. Yes. Okay. So now this is a 44, right? Log 34, 1 over 5, 0 to infinity to the power minus 7 over 5, x2 dx2, 5 to the power 5, 25. Okay. Now 44 plus log 34 plus 1 over 5. And this is e to the power minus 7 over 5 x2 minus 7 over 5 infinity to 0 plus 5 e to the power 5 plus 25. Okay. So now if you do these things, 44 plus log 34 plus this is a 1 over 7 and then plus 5 e to the power 5 plus 25. Let me compute these things, what I got. 44 NP dot log 34 plus 1 over 7 plus 5 times 5 times np dot exp 5 plus 20 times np dot phi. 852. Understand? 852 is the theoretical mean. Similarly, we can find theoretical variance like this. Variance of y, if we find, and then 9x1, 9, variance of x1, and then log 34 gone, variance of e to the power minus x2 plus variance of x3 e to the power 5 square, variance of x3 plus 5 square variance of x4, 5 square variance of x4 plus variance of e. That's the way you can find the theoretical mean and variance, okay? That's the way you can find theoretical mean and variance. Okay. So it is just plugging the value, only derivation involves in here. There is the only derivation. This value is given, that value is given. So second term variance of e to the power minus x2, that derivations you can do. I can do it, but I do not have a time to do all of these things. If you want, I can do this and send it to you by email. So purpose is, I have a equation. From that equation, I want to simulate the data. I want to find and compare theoretical mean and variance with the simulated mean and variance. Clear? Theoretical mean and variance with the simulated mean and variance, I want to compare. That's the purpose. So now, let me take you there. This is what you need to pay attention, because after this, I'm going to discuss about your homework. I take the data from binomial, I take the data from uniform, I take the data from exponential, I take the data from normal. Right? See how I am writing. np dot random dot binomial 20 and 0.65 and comma n, and then np dot random dot exponential, and then I got n, and then np random dot uniform. See, everything is a function of n. Okay, everything is a function of n. When I after writing all of this x1, x2, x3, x4, and e, after writing all of these things, I plug these things in here, equation format. Are you seeing? And then I am writing y1 is pd dot data frame. I am now putting y in a data frame format. After putting data frame format, I return y1. That is my simulated data. Now I put sim equal to 100, 100 y1 will be generated. If I put there 1000 y1 will be generated. Clear? So this is the way I generated the data, and this is our sim data. After sim data, this is the C1. There is 100 observations. These are my 100 observations. So if I want to find the descriptive statistics, this is the summary statistics. And are you seeing mean equal to 847? Our theoretical mean was what? 852, right? Very close, right? 847. Or in the code it is different? Why? Let us go.
Exponential. Exponential, what was said in there? Yeah, so mean 5 means 1 over y. This is just 1 over 1, this is 5. Variance does not need to specify in here. Which one? Normal. Mean was what? So standard deviation is 3. Now, thank you very much. At least you are following. You are not letting me go free. You understand? They are asking, yeah, it's 9, but the way you formulate, it should be standard deviation. It should not be variance. Yeah? So data is generated, right? Data is generated. So now descriptive statistics done. I want to do it 50. Take a look at the line number 118. Line number 118 would be very important for you. Take a look at the line number 118. Same 100 mean I am simulating or generating 100 data points, but I want to replicate this randomly 50 times. Understand? Same, repeat, same this for I in the range like that. So now that 100 times 50, 5,000. This 5,000 data has been put together in here. And then I find their mean and variance and compare with the real data. So this is the all data. And theoretical mean and variance. Okay, now I want to do it 100 times. 100 times, this is the 100 times. Now I want to find the theoretical mean and variance. See, the theoretical mean and simulated mean difference. Absolute difference between simulated mean and theoretical means is 0.79. Clear? So if difference between theoretical and simulated mean is very small, that simulation design consistent with the theoretical design, right? Theoretical mean. Take a look what I got in here. 0.79. Okay? But variance difference is higher. Variance difference is 2122. Why? Why variance difference is high? Why variance difference is high? Simulated variance minus theoretical variance. The difference is 2122. 2122. What was the theoretical variance? 1,81,000. So that is a very big number, right? So variance, theoretical variance was very big. So that is why 1,182,000. 182,000. And then simulated variance and theoretical variance differences. Like 2,000 difference if the theoretical variance is 182,000 and then simulated variance is like 2,122, their difference is not that big. Understand? So if this guy has a 182,000, he lost $2,000, that will not give him a big pay. Unless he is a very mean person. Unless he is not a generous person. You understand what I'm saying? 180,000 variance is a very big number, right? So that is right. But if you still want the minimization of that, what do you have to do? If you want to reduce it further, what you will have to do? Good. Increase the repetition. B, that B, you can change it to maybe 1000. And sim, you can do it to the 10,000. And if you really want to give a very, very hard time to the computer, 2-3 days of computation, you can add here a couple of zeros. You can add here a couple of zeros. Then computer said that, well, is there any way you can excuse me? I said, no, do it. For the next 3-4 days, you will do all of these computations, okay? When there is a complicated model, when we are doing PhD with a time variant, time invariant, all of these things in model after model, we are running the computer, but write a note, 2012, 13, 14, write a note, simulation is running, please, any user must not shut down the computer. Okay, so if you run like this way, see, I don't know how long it will take. I have to kill this program, I guess. See, he's thinking. I told you. He's thinking. Understand, right? And in that case, maybe the difference will be little lower. I don't know how long it will take. Now I'm going to discuss about your homework. This part is done. Yeah, homework. Let me see my, it is still working. Okay, there is a way to kill this. This is the way to kill it? Yes. Stop the current command. Yeah, take a look something. If you run something very big accidentally, if you click on there, it will stop, okay? Are you seeing? If you click in there, it will stop. Okay, let me kill it. Gone. Now your homework. Take exactly 3 minutes break, okay? I want to discuss something so that you can make your temperament very cool. So the homework problem for the simulation I will discuss. 3 minutes break, then I will discuss. Oh, thank you. Oh, you didn't sign? Sign. I see like the people who joined online. I saw your name. Eric, Hassan, and Subira, as well as Hassan, yeah, Hassan, Eric, Subira, and Vaishnavi. 4 of you joined the class. I saw that. Hassan, Eric, Hassan, Eric, Subira.
Okay. For your homework, please give few minutes. Please pay your full attention what I'm going to talk. I have given two problems. Time variant simulations from probability model with fixed parameter. And time variant simulations from probability model with variable parameters. Okay. So when you simulated data from binomial distributions, probability was 0.65, right? Right? Probability was 0.65. For example, take a look at the Python code. Are you seeing there? Probability 0.65, right? That is the fixed. You put the 0.65, they are randomly generating numbers. Sometimes 4 success, 4 head, sometimes 7 head, sometimes 9 head. Okay? But the second one, I said that variable parameter. So that means you have to put a variable parameter. Let me read the question. Simulated data of 25,000. That means you have to write a function like sim. That has variable a's. You have to simulate a data something like this. Take a look what you will have to do. There should be a's variable. Okay. Then a's variable. Then what happened? Oh, it is not. So you have to create a variable name a's. Then you have to create a variable a's variable. You have to create a a's variable. And you have to create a success variable. You have to create an accident variable. You have to create events variable. You have to create time variable. And you have to create income variable. Clear? Clear? Now, age variable you create, that will have a age 1. That will have a age 1, 2. What happened again? So you have to create a age, success, accident, events, time variable, but that variables, all of these should be in a data frame format. So let me show you what you will have to do. Are you seeing I created a sim data, right? Sim. You write here age, and then you write here accident, you write here events, you write here time, you write here income. Understand? Clear? And then you plug the parameter value, you will generate this thing. Clear? And then I combine them in here, but you must not create line number 109. 109 means what? All of these things has been put together as a one equation, but you should not do that. Are you understanding? So line number 104 will be age, then accident, then events, then income, then all of these things, and you put all of these things in a data frame format like this. It should be a data frame format like this. Clear? It should be data frame format like this. What you will do after creating age, accident, event, income, all of these, you put them in a data frame format. After data frame format, what you will have to do? You have to take help from here. Are you seeing line number 467? This is what you have done in your homework, right? So line number 467 is doing what? Rows for underscore rows in D1. D1, right? D11. Your data will be data frame. Your data will be data frame group by new age. Your group by will be age variable. Clear? Okay. After doing that, what we will do? Take a look what I ask you. I ask here, split the simulated data by age variable. So you splitted the data, right? So at age 1, you have a data. At age 2, you will have a data. At age 19, you have a data. At age 100, you have a data. How many data you will have? 100 data. Corresponding to each age, you will have a data. For each of these data, you have to find the mean for the accident, mean for the time, mean for the events, all of these things. You understand? Clear? Let me again show you the code where you will have to make a manipulation change. Code is this one. You write a definition sim of n and x1, x2, x3, x4, maybe x5, all of these things you will write. You must not write all of these things combining like that way. Understand? You must not write y. Y is doing what? All of these variables are putting together to create a y. But you are not going to do that. You have a data frame. You have a data frame like D11, you have a data frame. You have a data frame like this. This is your entire data frame. You will have an entire data frame. That data frame you will put in a pd.data frame format. After putting that pd.data frame format, this y, after that you will run. You must not run this line of code. Okay. After that, you put this, like put the comma in here, put x1, x2, x3, x4, all of this. We'll have to put comma, something like that, comma, x1, x2, x3, x4, all of this. After putting that, you will borrow this line of code. You will borrow line 467 and put it after there, after data frame. And then you will find the mean. Then you will find the mean with respect to each data set. Okay. And then everything you will write within this sim function. Outside this sim function, you just call sim equal to 25,000. Then they will give you all the mean. Clear? Are you understanding? Second problem is telling you what? Second problem is telling you, here I put 0.65, right? 0.65, right? Yeah. Second problem is telling you, instead of 0.65, you need to consider this type of thing. Let me do these things. Control V. So I ran both of these. I got x1 equal to this. Take a look at the board. Second problem. Second simulation, same type of thing. Only difference is this. Are you seeing the difference between these two? 2020 is fine, fixed parameter, but here it is a variable parameter. What does this mean? np.random.uniform. 0 to n take numbers. That means probability. 0 to 1. 0 to n means all are probability, right? Binomial has a success probability P. P equal to 0.65 was in there, but here it is take n P and then generate n. Each will come with that n probability. You understand or not? Take a look at the question again. Where is the question? Document, class practice. Where is the document? Here. Here.
Are you seeing time variant variable parameter? Are you seeing the word variable? Variable parameter. So I say, take a look at the question. In this simulation design, which simulated data of size 25,000, it should not be 2,500, 25,000, okay? From various probability models under the assumption that data will be generated with varying parameter values, where age takes value from 0 to 100. Age 1 is fine. The probability models are binomial. Parameters n equal to 10, p equal to 0.47, 0.4 to 0.7. Poisson parameters between lambda equal to 0.65, lambda equal to 10. Are you understanding? Previously, lambda has a 1 value, right? But now lambda has a different value. And the geometric distributions previously, p has a 1 value, now p has a different value. Exponential distribution, lambda has a different normal parameter, mu 10 to 20, sigma equal to 10. The rest of the thing is same. Split the simulated data by age variable, compute mean for each age of the simulated data. And then randomly replicate that things you can ignore. Okay? Randomly replicate that. That is also easy. What you can do, whatever you have found, just write the repeat code that I have written in there. Clear? So what you will learn from there, how to do simulation when parameter of the probability model are fixed, parameters of the probability model are variable. So in this case, are you seeing here random exponential? I put unique parameter here, which is equal to 5, right? You have to specify it in here different numbers, between numbers. So the parameter value will take different number. That is what you have to identify. Okay, you have to identify uniform. Uniform is not in there, maybe. From random, this is your mean, this is your variance. Variance equal to 2, but mean will be varying between numbers. Okay, clear? And then you split the data. After splitting the data, you will get the result. Okay. So next Tuesday, you will have an exam in here. So 65 data analysis, data mining problem, and 30 problem of function computation matrix, right? So 2 Word document, read those Word document multiple times and run each line of code multiple times. Okay. So it is open book, open note exam. So 30 to 40 problems will be given. Okay. Be very quick in doing those things. You will come and occupy a seat by leaving one place blank. Okay. Leaving one, and you will start sitting from the front. You will start during the exam time. Your email must not be open. I will be sitting in the back. Your email must not be open. WhatsApp must not be open. In computer, logged off WhatsApp, I do not want to hear any listen, any sound that WhatsApp is going. I will be very strict and become a very strict Asian professor next week. Because that is relevant, right? This class is like dominated by the Asian. I am Asian, you are Asian. One is outlier. Okay.
All these can be used as reference.
Yeah, so open book, open note, and you can Google it. Okay, you can Google it. But you are not allowed to use email, WhatsApp totally switched off, okay, completely in your phone as well as. The reason I'm doing this strict policy, because next 1 week, if you work hard all of these things, you will become familiar with this. Okay, memorization sometimes helps. We in our country when we did our undergraduate, there is no cheat sheet, there is nothing. Everything memorized, and even after getting the questions, immediately write all of those formulas. Like in statistics, test of evidence, all of those things. I'm sitting in the front when the professor is saying, I didn't give you the question. Why are you saying? Professor, I will forget. You give me the questions and you saying I'm writing all this. This is now my exam. I'm writing all of it. So you will forget that's the way you are writing. Yes, I'm writing now, but I'm not copying from anything. Nothing, right? Except the table or anything. So I really want you to be very successful. That's the reason I want you to take this exam like that. What?
Is it a mid-exam?
Mid-exam, yeah. Then another exam I will give you at the end of the semester, okay? So after the exam, maybe I will start doing statistical modeling or text mining, and then I will do statistical modeling, okay?
How to make the movie?
1 and 2. Okay? All of those like the 100 problems, right? Altogether, 100 problems. So take a look at the code, try to understand the code and do this.
So around 30 problems I will give. Any questions from people in online?
Yeah. Is it this week included on that exam or is it just the previous weeks?
It is, the exam will be on the next week during the exam time.
So is it are we including material from this week or from the
No,
previous
no, no.
week?
Now materials from first to homework, okay?
Okay. Do you have the live stream from last week? I didn't see that uploaded.
Oh, you want my last week live stream class
didn't-
upload in the Western Online?
Yeah. I got lost toggling through screens a little bit
Okay.
last week.
Okay, so would you please email me so that I can upload it today?
Okay. I'll email you I'll probably email you around the time I email my homework in. Okay.
Okay.
Thank you.
Yeah. Thank you. Bye. I'm going to stop in here.